Hello. Today we're going to take a look at solving polynomial equations. Now, we have done a lot of lessons previous to this one dealing with polynomials and factoring things down and things like that. In today's lesson, the difference is that we are trying to solve very complex polynomials and break them down into all of their roots. So we're going to be doing a lot of factoring. We are going to be learning some new ways to find different roots and things like that. So we're going to be kind of pulling out all of our tools from that factoring toolbox in order to come up with our equations for this. Now, just a forewarning, this is probably one of the most frustrating lessons, and each of the problems has a potential to take a very long time. Now, I want you guys to know that I've pre-worked most of these problems so that I know the quickest way to get to the answer. Now, it might take a little bit longer for you if you're doing a problem for the first time. So that's just a little forewarning going into this, but just to be on a time constraint, I've worked things out, but I'll show you guys how to get to each of those possible solutions. But part of this lesson, there's a lot of guessing and checking that takes place. So starting off, our warm-up vocabulary. The formula x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a is called the quadratic. Quadratic formula. The second one, if we want to factor 27cd cubed minus 12cd, first off, we should know with our numbers we can take out a 3, we can take out a c, and then we can take out a d. So I'm going to take out a 3cd. That's going to leave me with 9d squared minus 4. Now that second part is a difference of squares, so we can break that down into 3d minus 2 and 3d plus 2. The next one, if you are solving when those two things are set equal to 0, one of our answers, we just have x on the outside, so that x would be equal to 0. And then x minus 4 equals 0, we just have to add 4 to both sides, so x is equal to 0 and 4. Last one, solve x squared plus x plus 1 by using the quadratic formula. So x equals negative b, which is 1, plus or minus the square root of 1 squared minus 4 times 1 all over 2. So that's going to give us negative 1 plus or minus the square root of 3i all over 2. And I would just leave it like that. Okay, now starting off. Sometimes a polynomial equation can be solved just by factoring and using the zero product property. This is probably what we are most familiar with and most comfortable doing. So let's take a look at a couple examples using that zero product property. So if I'm looking at this first one, 2x to the 4th power minus 10x cubed minus 72x squared equals 0. Zero product property, we have that set equal to 0. So we just have to look at each of those terms and say what is the most that I can take out of this entire polynomial. So we should know that we can take out a 2 as far as the 2, 10, and negative 70, or negative 10, negative 72. We can also take out an x squared. So on the outside, we have 2x squared. That leaves us with an x squared minus 5x minus 36. Those are both equal to 0. And then we look at that trinomial. We say what multiplies to get negative 36, what adds up to get negative 5. That's x plus 4 and x minus 9. We still have that 2x squared out front. So if we're solving this completely, which is what we'll be doing if we are solving these polynomial equations, we have 2x squared is equal to 0, divide by 2, and take the square root. We know that anything out front with an x, that's going to be x equals 0. X plus 4 equals 0, subtract 4, x equals negative 4. X minus 9 equals 0, add 9 to both sides, x equals 9. Okay, for our next one, if we're using the zero product property, we have to have those set equal to 0, so we have to subtract that 4x squared from both sides. So I'm going to rewrite this guy. Plus x equals 0, and then I'm going to take an x out of everything. So if I do that, I'm left with 4x squared minus 4x plus 1. So if I'm trying to factor down that 4x squared and that 1, I'm going to try this out. So I'm going to try a 2x and a 2x. And if they multiply to get a 1 and add up to get negative 4, I'm going to try a minus 1, minus 1. Still have that x on the outside. It's still set equal to 0. So then, just to kind of guess and check, or to check this out, you can FOIL. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Do that again, you get negative 4x. Negative 1 times negative 1 is positive 1. So those would be our factors. So we have an answer of x equals 0. And then I have 2x minus 1 equals 0. From both sides we would add 1. We get 2x equals 1, divide by 2. So we get x equals 0, x equals 1/2. Those would be our two answers there. And you notice we actually have two answers that are 2x minus 1, so we'd have two answers of 1/2. And that kind of jumps right into this concept of multiplicity. Notice that from example 1b, that the solution or root of 1/2 appears twice. This is called a double root. It has a multiplicity of 2. So then multiplicity of roots, that definition, the multiplicity of a root r of a polynomial equation is the number of times x minus r is a factor of the polynomial. So if you have a repeated root, how many ever times that root is repeated, that would be the multiplicity. It's simply just counting how many things are the same. Find the roots of each equation, give the multiplicity. So if I take a look at that first one, again, this isn't too bad because I can take an x cubed out of everything. So I'd be left with x squared plus 8x plus 4. That's all equal to 0. And that second piece would factor down to, I wrote that out wrong, that's a 16, not a 4. Jumping the gun. There we go. So then we have x cubed out front. This can be factored down into x plus 4 times x plus 4. So x is equal to negative 4, because we could subtract 4 from both sides, has a multiplicity of 2. And x equals 0, because we have that x cubed out front, that actually has a multiplicity of 3. Okay? And then that next one, we actually want to do, we want to make sure that we have everything set equal to 0 again. So we have x to the 4th minus 2x squared minus 1 equals 0. Well, this might look difficult, but it's still set up as like a perfect square. So if we break this down, or in perfect squares, we would have to have x to x squared, or we could have x cubed and x, but that really wouldn't work out. and then we want to multiply to get negative 1. So that would be, oh, and again, I kind of screwed up there, because that should be a plus if we're moving that over. So we would end up with a negative 1 and a negative 1, the way that that would factor down to add up to get negative 2x squared, but multiply to get a positive 1. So this here is a difference of squares. So we'd have x minus 1 and x plus 1, and another x minus 1 and an x plus 1, all equal to 0. So x equals 1 has a multiplicity of 2, and x equals negative 1 has a multiplicity of 2. Okay? So again, multiplicity is just how many times that factor occurs. So because we have 2 of those and we have 2 of those, they each have a multiplicity of 2. All right, now this is the tricky part. So it's the rational root theorem. Polynomial like x cubed minus 2x squared minus 11x plus 12 equals 0, where the degree of the polynomial is greater than 2, can be factored by using synthetic division if one of the factors is a linear binomial and is already known. When none of the factors are already known, begin factoring the polynomial by using the rational root theorem. So this is kind of our process in going through solving problems where we're not given one of the factors already. So if a polynomial p of x has integer coefficients, then every rational root of p of x equals 0 can be written in the form of p over q, where p is a factor of the constant term and q is a factor of the leading coefficient p of x. The irrational root theorem states that irrational roots come in pairs. So if polynomial p has rational coefficients and a plus b root c is a root of p of x equals 0, where a and b are rational and root c is irrational, then a minus b root c is also a root of p of x equals 0. So that second one, all they're saying is that if you have a plus b root c, then you also have the minus. That top one is kind of the process in solving through some of these problems, and it can be tricky because we're using factors and you have a lot of options. So I want to show you guys just kind of the process, and like I said at the beginning, I've already worked through these problems, so I know kind of the right route to take. So we have a 12, and we have the coefficient of our first term would be 1. So the factors of 12, they tell us that we would have p over q. P is that constant term, or the factors of our constant term, which would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. Okay, so like I said, there's a lot of options. The bottom one is just plus or minus 1. So we could have 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, 6, negative 6, or 12, negative 12. Now we have to pick kind of the right term in order to, or we have to pick some factor. We just have to pick something, and if it doesn't work out, what we're doing is we're using synthetic division, and we're hoping that we get a remainder of 0. Remember that if we get a remainder of 0 in synthetic division, then that is a factor for us. So like I said, I've already worked some of these through, so I'm going to use x plus 3 as a factor, which means that I would use negative 3 in using synthetic division. I'm going to put those coefficients 1, negative 2, negative 11, 12. Drop that down, we get 1 times by negative 3, add those together, negative 5, multiply, positive 15, positive 4, times negative 3 is negative 12, and we get 0. So I have x plus 3 as a factor, and then this would turn into x squared minus 5x plus 4. So what multiplies to get 5, but adds up to get, or what multiplies to get 4, but adds up to get negative 5, that would be x minus 4 and x minus 1. And don't forget, we still have that factor that we came up with using the rational root theorem. So each of these is our factors of this problem. In solving, we would get x is equal to 1, 4, and negative 3 would be our 3 answers for this. Each of those has a multiplicity of 1 because each of them only occur one time. Now the next one, doing it the same way. So we have 3x to the 4th minus 5x cubed minus 29x squared plus 3x plus 4. So in this one, we have p over q. That would be plus or minus 1, plus or minus 2, plus or minus 4. In the bottom, we'd have plus or minus 1, or plus or minus 3. So working these out, again, I've already worked these out, so I already know the ones that work out. Make sure that you give it a chance. It's not hard, it's just a lot of work to find the right one. So we have 3, negative 5, negative 29, 3, and 4. Now I know that 4 works out. Bring that 3 down, times by 4, we get 12, 7, 28, negative 1. That would be negative 4, negative 1, negative 4, 0. So now we would have 3x to the 3rd plus 7x squared minus 1x minus 1. And we would have to do the same thing. So we would again have to do p over q, and we would just have plus or minus 1. And then we would have plus or minus 1 or plus or minus 3. So in solving that second time through, 1/3 is one that works out. And again, I just know that because I've already done it. So here I would have negative 1/3. So that means we'll have a 3, 7, negative 1, negative 1. Bring down your 3 times negative 1/3, we get negative 1. 6 times negative 1/3, I get negative 2. I get negative 3. Times by negative 1/3, we get positive 1 and 0. So then lastly here, we've come up with two factors, x minus 4, x plus a third. Now we have this 3x squared plus 6x plus minus 3 equals 0. And for the last part, we need to use the quadratic formula. Now each of those has a 3, so you can take a 3 out and simplify it down to x squared plus 2x minus 1 equals 0. Again, we're using the quadratic formula, so x is equal to negative b, so that'd be negative 2 plus or minus the square root of b squared. 2 squared is 4, minus 4 ac, that'd be times 1 times negative 1, all over 2a, so all over 2. Let me group these guys together real quick. Okay, simplifying this, we get negative 2 plus or minus the square root of 8 all over 2. I know that the square root of 8 is 2 root 2. I forgot a negative that last time. Plus or minus 2 root 2 all over 2. So this would be our irrational roots. Negative 1 plus or minus root 2. So that's 2 answers right there. And then we still have, we would have x equals 4. We'd have x equals negative 1/3. Okay, that's as hard as it gets. Now, it takes a lot of time if you don't already know those roots because you have so many options a lot of the time. So re-look at this example, rework it, try some out on your own. Don't just give up on this. I know it's a lot of work, but it's all steps that we know how to do. We can do synthetic division. We can use a quadratic formula. It's just all about actually taking the time to do it and putting in that work. All right, and then using a calculator. So we also know how to do this. If you're using a graphing calculator, let me move this over. Our next example, our equation is x cubed plus 5x squared, plus 5x squared minus 9x minus 10. And again, we're interested when that is equal to 0. So it looks like I'm actually going to get all of the zeros right in that picture right there, which is pretty nice. I'm just going to switch it up just so we can see it a little bit better. So I'm doing a zoom fit. Again, remember what I said before. We always want to check the table to see if there are any whole numbers. So it looks like at 2 we have a 0. So I'm going to add that even though you guys can't see it. We have x equals 2 when y is equal to 0. And then we'll check those 2 negative numbers. So it looks like we'll just jump right back into the graph. Second trace button to calculate. Number 2 is the 0. Left bound, I'll check this very left one first. To the left of it there. Right bound just barely comes above 0. Take a guess. So negative 6.19. That'd be good enough. Now we want to check the second one, so we do that same thing. To the left of it, to the right of it, take a guess, just get a little bit closer. And x equals negative 0.807. Okay, that's in using a calculator to solve these. So those are our 3 answers that we could find. Use the trace or the calculate in the 0 function and take a look at your table in order to find those. So a little bit more doable if you have a calculator for sure. Tools can be very, very helpful in solving difficult problems. Last one. Box is designed so that the height is 6 inches greater than the length and the width is 3 inches. I think it was supposed to be, one was supposed to be greater, one was supposed to be less. What must the length be if the volume has to be 40 cubic inches? So we should have, our length is just x, our height should be x plus 6, and our width should be x minus 3. That's all going to be equal to 40. We want to FOIL this out, so we would have x squared minus 3x plus 6x minus 18. Combine like terms, and then we'll throw that x into each of them, so that'd be x cubed plus 3x squared minus 18x, and then we would have minus 40 is equal to 0. So again, we want to use the rational root theorem. We have a negative 40 at the end, so we want to find a factor. So we would have that P over Q, all the factors of 40 plus or minus 1, all the way to plus or minus 40, and then we would just have plus or minus 1 on the bottom. So one that's going to work out for us would be negative 4. So I can put a 4 here for synthetic division. 1, 3, negative 18, negative 40. Bring a 1 down, times by 4, 7, 28, 10, 40, 0. So this would end up being x squared plus 7x plus 10 equals 0. Almost done. So that would be x plus 2, x plus 5, and what we had before, x minus 4. So some of these answers aren't going to make sense because we're in a real world situation. Now, since we have to be positive, I can't use those two second ones. So x plus 5 and x plus 2, if I actually solve for x, I would get two negative numbers. So x is going to be equal to 4. That's the only thing that makes sense. So if I go back up to my problem, we have a length, which was this x of 4. We would have a height of 10, and we'd have a width of 1. That would be the dimensions of that box. That's everything I have for you guys today. I hope this was beneficial for you. Again, this is a difficult lesson. Make sure you take the time on it, and I'm really hoping that you guys are successful on it. Have a great day.